So this is theorem 11.2.4. Let R of t and S of t be differential vector valued functions. Then we're going to let f of t be a differentiable real valued function and c be a real number. Then the following 6 things hold. Number 1, if I take the derivative of the sum or difference of the two vector valued functions, I get the sum and difference of the derivatives. Number 2, if I take the derivative of the vector valued function multiplied by a real number, all I do is I bring the real number out front. Number 3, if I take the derivative of a vector valued function multiplied by a real valued function, then I have the first times the derivative of the second plus the second times the derivative of the first. Product rule. Number 4, if I take the derivative of the dot product of two vector valued functions, then it's the first times dotted with the derivative of second plus the derivative of the second dotted with the first. Oh, I probably messed that up, but you can see it right there. Okay? The derivative of R cross S is equal to R cross the derivative of S plus the derivative of R cross S. And the last one is the derivative with respect to t of the vector value function composed of a real differentiable function, f. And so this is the chain rule. I take the derivative outside, evaluated f of t, and then multiply by f of t, f prime of t. All right, so we're going to take that, we're going to calculate or do some examples here. Given R of t is 1 over t, comma, negative 1, comma, ln t. And S of t is t squared, comma, negative 2t, comma, 1. And I'm going to write this like this here. So I'm given these two functions here. And the first thing I want to do is I want to find the derivative with respect to t of R of t dotted with S of t. Okay, so R of t dotted with S of t. Well, let's see what we can do here. Okay, looks like we're going to need R of t and R prime of t. So we need R of t and R prime of t. We're also going to need S of t and S prime of t. Okay, so I'm going to calculate R prime by taking the derivative. Now the derivative of 1 over t, if I simplify or if I make this t go into the numerator to make it easier to differentiate, that becomes t to the negative 1. And so when I take the derivative, I get negative 1 t to the negative 2. Okay. The derivative of negative 1 is 0. The derivative of ln t is 1 over t. Or you could write it as t to the negative 1. All right, so that is negative 1 over t squared, comma 0, comma 1 over t. not 6, but t. Okay, so that's r prime. Now, s prime, take the derivative with respect to t. What do I get? I get 2t, comma, excuse me, negative 2, comma, 0. Okay? So let's calculate this both ways. I want to, if the homework question says to verify, okay, verify, then that means it wants you to calculate d dt r of t dot s of t. And then it also wants you to calculate the formula, which is what? The first dotted with the derivative of second plus the second dotted with the derivative of the first. Okay? So, to do this, I've already got the players. I can do this side here by just plugging in r of t is 1 over t, comma, negative 1, comma, ln t, dotted with s prime of t, which is 2t, negative 2, 0. Okay. And then I add that to s of t, which s of t is this right here. So that's t squared, comma, negative 2t, comma, 1, dotted with r prime of t. So r prime of t, which is, I like that version there. Okay, so I'm going to do negative 1 over t squared, 0, and 1 over t. So when I simplify that, this first piece here, when I dot, I multiply the components together and then sum them up. Okay? So when I multiply 1 over t times 2t, I get 2 plus negative 1 times negative 2, which is 2, plus ln t times 0, which is 0. So the first part is 2 plus 2 plus 0, which is 4. Okay. The next part is going to be t squared times negative 1 over t squared, which is 1, negative 2t times 0, which is 0, and 1 times 1 over t is 1 over t. All right, now I made a little bit of a mistake because this is actually a negative and that's a positive, so this needs to be a negative. Okay, so subtract that. All right, so 2 plus 2 minus 1 gets me 3 plus 1 over t. Okay? Now, if I want to verify it, then that means not only do I need to do this right side, but I also need to do the left side. So the left side says dot it first. Okay, so if I dot the 2 first, and then I take the derivative, what do I get? Well, 1 over t, comma, negative 1, comma, ln t, dotted with t squared, comma, negative 2t, comma, 1. Okay, that's the derivative of, all right, multiply your first components together, you get 1 over t times t squared, which is t, I believe. Negative 1 times negative 2t, so that becomes positive 2t. And then ln t times 1, that's ln t. Okay, then I take the derivative of this, derivative of that is 1, plus derivative of this is 2, plus derivative of this is 1 over t. So does that equal that right there? Yes. That's what I mean by verify. Okay, so you do the left side, you do the right side. Okay? Now in this instance, it seems like dotting it first and then taking the derivative is easier. But that's not always the case. Sometimes it's better to take the derivatives of the individual r of t's and s of t's and then dot them together. But in this case, it said verify, so that means you got to do the left side and the right side to verify that they're both equal to each other. Okay, the next thing that I want to do is I want to do d dt r of t cross s of t. Okay, I want to calculate this. All right, so to do this, I think what I'm going to do is I'm going to do the cross product here and then take the derivative. That's what I'm thinking. Okay, so remember r of t is what was r? R was 1 over t comma negative 1 comma ln t, and then s was t squared comma negative 2t comma 1. Okay, so to do the cross product, remember we have I, j, k, I, j. And so ijk, so r cross s is going to be 1 over t, negative 1, and then ln t, and then 1 over t, negative 1. Then for the s row, I'm going to have s squared, negative 2t, 1, t squared, negative 2t here. Okay? So now I'm going to do my cross product, and I need to multiply through the diagonals like so. In the first one, I subtract the multiplication. So this becomes minus t squared k. And then I have minus 2t ln t for the I component. And then plus 1 over t for the j component. And then I'm going to add it to, I want to do the diagonal going the other way. So 1, 2, 3, going this way. So this would be negative I, and then plus t squared ln t j, and then minus 2, t over t cancels, so 2k here. Okay? And so when I combine these components together, the i's, negative 1, and this negative 2t ln t come together to get you that first component, 2t ln t minus 1 for the I component. For the j component, I have a minus 1 over t, and then I have the t squared ln t part. And then for the k component, I have minus a minus, which is now going to be plus t squared, and then minus 2. Okay, so this is the cross, so this is equal to r of t cross s of t. And what I want to do with this, well, that's not a good color. Here we go. What I want to do with that is I want to take the derivative of that with respect to t. So d dt, the cross product, what do I get? I get, okay, the first component is 2x or 2t ln t, which is a product of two functions. So that's a product rule. So I need to do first times the derivative of second. So the first is 2t times the derivative of second is 1 over t, plus the second ln t times the derivative of 2t, which is 2, minus the derivative of negative 1, which is, that just goes away, okay? The next one, I have another product rule, t squared and ln t. So I have the first times the derivative of second, plus the second times the derivative of the first, and then minus, okay, now 1 over t, the derivative of 1 over t is negative 1 over t squared, but the negative and the negative make a positive 1 over t squared. Look, do side work off to the side. If this is too much for you, this becomes negative 1 t to the negative 1. When I take the derivative, okay, the derivative with respect to t of negative t to the negative 1, the negative 1 comes out front, you get positive 1 t to the negative 2, which becomes what? 1 over t squared. So that's where that piece came from, okay? And then the last component, derivative of t squared is 2t. Derivative of negative 2 is 0. All right, I can simplify this a little bit. The t cancels with the t here. One of the t's cancels with one of the t's there. And so I end up with 2 plus 2 ln t, comma, t plus 2t ln t plus 1 over t squared, and then 2t. All right, so a lot of work there, but that would be, as long as that took, that would still, I think, be the fastest way to solve it, because look, if we had to use our rule here, not only would you have to do one cross product, you'd have to do a second cross product to use the rule. So 2 cross products there is not going to be, it's going to be double your work basically. Okay, so just do the cross product first, then do the derivative with respect to t. But look, if it says to verify, that means you got to do the left side and then do the right side as well. So that's just a lot of work, but it's meant to give you more practice with the cross product so that you have a better, longer time to memorize it. It sticks in your brain a little bit more the more times you do it. So everything that is done in this class is done for a purpose. And so I'm trying to develop your algebra skills and your calculus skills so that when we get to the harder sections of Cal 3, it can just be, I can just say, hey, we got to do a cross product here. And you think, oh yeah, okay, cross product. I got 2 vectors in the same plane, and it gives me, the cross product gives me a vector that's orthogonal to those 2, right? So these vector value functions, kind of a abstract idea going on here, okay? But we're just trying to get you to do the cross product over and over and over so that you get better at it. Okay, So now that we've done limits, continuity, differentiation, let's go to integration. Okay, and I'll do that in the next video.